Now let's look at simple harmonic motion. An object that moves on a coordinate axis in simple harmonic motion, if its distance from the origin, d, at a time t, is given by d as a cosine omega t or d as a sine omega t. The motion has an amplitude a, which is the maximum displacement the object is from the rest position or the equilibrium position, and the period of the motion is 2 pi over omega, where omega is always positive. The period gives the time it takes for the motion to go through one complete cycle. The motion has a frequency f of omega over 2 pi. Now suppose a ball on a string is pulled 6 inches below its rest position and released. The period for the motion is 4 seconds. Write the equation for the ball's simple harmonic motion. Well, let's use a cosine function because the ball is pulled from the rest position downward to start. So I know 2 pi over omega has to equal 4. So omega is pi over 2. A is -6 because we pulled it down. All right, so D is a cosine omega t. So it's -6 cosine pi over 2t. Now let's calculate some simple harmonic motion. A mass oscillating up and down on the bottom of a spring can be modeled as a simple harmonic motion. If the weight of displacement is a maximum of 4 centimeters, find the modeling equation it takes if it takes 3 seconds to complete one cycle. Assume it starts at rest. So let's assume it starts at the origin when t equals 0. And let's use a sine model. D is a sine omega t. The maximum displacement A is 4. The period is 3 seconds. So the frequency is 1 over the period, or 1/3. So I have 2 pi over w is equal to 3. So omega is equal to 2 pi over 3. So the modeling equation is D is equal to 4 sine of 2 pi over 3. A tip on the point of a tuning fork vibrates in harmonic motion described by the equation D is equal to 12 sine omega t. Find omega for the tuning fork if it has a frequency of 386 vibrations per second. So I know W over 2 pi has to equal 386. So a W has to equal 772